Everybody. It is the 6th of September, 2023. This is Plutus PBL live coding, and here's the crew. Hey, everybody. This course has been running since March of 2023, and now it's September. We've been going for about 6 months and just gradually starting to roll out. People have been moving at their own pace, and we set the goal of getting at least 12 people to the halfway point of the course before continuing to publish. And I got to apologize to everybody who hit that deadline. Y'all did it at the latest. Let me just check right now. Now that Sebastian did it, we've got 14 people who have finished module 204 and are halfway through the course. So mission accomplished, goal exceeded. And our team just needs a few extra days to get module 301 out. I'm sorry that it's not published yet, but we met about it yesterday, and we'll be ready to go live on Monday. So 5 days from now, 11th of September. And then we'll start rolling out additional 300 level modules after that. Really excited to get into that. One of the ways our team's thinking has evolved since initially publishing this course is that when we first rolled it out, we made a very clear distinction between specializing and contributing in the PBL framework. And we even have an image. I'll pull it up on the screen right here. Here's the dashboard, by the way. Newman, thanks for the link. So in the course, we can see how many people, like I was just saying, have completed module 204. Once again, nice work. But when you get started in the course, we introduce this framework that goes from onboarding to contributing. And we realize this message is actually a little bit misleading. Specializing and contributing don't always happen in sequence. They kind of happen in parallel all at the same time. And often, one of the best ways to specialize in something is by trying to contribute and finding out what you know, what you're already good at, and where you need to learn more. So this diagram right here needs to be revised and to show the cyclical process of specializing and contribution. And the reason I'm saying that right now is that's what you're going to see over the next few weeks as the 300 level modules start to roll out, where we start to go deeper into Plutus validators, different smart contract languages, and then different tooling for off-chain code. We're going to start adding opportunities to contribute directly into these modules. Okay, so I just wanted to share that as a frame and as a bit of coming attractions for where we're going. Very excited about that. A few people showed up as Juan and Nelson and I were working on the Andamio JavaScript packages. And that's an example of a place where we're building as we go the next version of the platform that we're using to deliver this course right here. And as we do, we're discovering that there's all sorts of interesting opportunities to teach new things, design patterns that we can add to the course, but also wrapped up in all of that, additional opportunities to contribute. No action needed today. I just want you to have that frame so kind of you know where we're going with this course as we roll into the next phase, and where more generally we're going with the Andamio platform, building out this set of tools where we've got the on-chain and the off-chain code working in tandem. So more to come. Any questions about those updates I just shared? Alex, what's happening? Good to see you.
Nice to see you as well. Pretty well. Actually, talking about some word that you said, but I was thinking about anything about apps where you have one smart contract sends something to another smart contract, and then you build logic out of that.
As a design pattern, is that something you want to look at?
Yeah, that's that's the word, design patterns. And yeah, that's what I'm looking at right now, slowly.
Excellent. Excellent. That's absolutely an example of something we can look at together. So before I get carried away, here's our Miro board for today. That. Newman, thanks for sharing the Miro in the chat. That's there for anybody who needs it. I'm just posting it again, just in case anybody just joined. And yeah, so for example, I'll finish this sticky right here. Alex, what I hear you saying is using, let's say, referencing one Plutus validator in another Plutus validator. Am I saying that right?
Yeah, maybe nobody knows really, because this is very new, and I am looking for just any, like, what could be done with it, at least, because like the idea is neat, but why bother?
Oh my gosh, why? Okay, why bother is such a good question. And a very short answer is this is a critical functionality of Plutus. The fact that we can reference one smart contract in another is exactly what allows us to build robust applications. So I can build a contract that can only send funds to another contract address. And when I do that, there's all sorts of ways I can play around with that. That's something we could absolutely look at anytime today or sometime soon.
Maybe
Nice.
soon, but I dropped, well, it's not hours, but, at least something to kind of some discussion about how this may work in general.
Cool.
Oh, what's that?
Yes, this is
Well,
from.
that's how DApp works. Just
Ethereum development best practices. That sounds interesting.
well, where can you look for innovation in Cardano?
I'm dropping that link here. That's excellent background. It'll be really interesting. I was actually talking to some people regarding tokenomics yesterday, and just, there's a ton to learn from Ethereum and how things work there, as long as we also keep in mind that the underlying architecture is fundamentally different. And so we have to learn as much as possible, use all the best practices that fit, but also not be limited, for example, in ways that the account model specializes, and comparing that to what we might be able to do with the UTXO model. And both absolutely have their advantages.
Just to throw this in here, I really am interested in understanding in a very, very nuanced way the UTXO model, and being able to, when someone asks me about it, like I sound like a Superman professional and know exactly what the benefit is and what the differentiation is. That I feel like would be that great background knowledge to just, that can set off, a lot of specialization and contribution. And there's a couple of UTXO model crash courses out there. I think we reference a few, and that would be a great, I'd love to focus in on that at some point with maybe a little mini circle or a carnival type, focused endeavor with our little learning community here. Yeah.
There's actually a critical connection between these two ideas.
Yeah.
And that's so. I know sometimes we take a little bit more of a dive into some technical details and then talk about possibilities and potential philosophies from there. If people want to dive into these topics today or soon, that's absolutely something we can do. That's cool. This module 204, putting the hex of the token name in the metadata.
Yeah. It's from a long time ago. I don't know if you remember.
Yeah. Oh, yeah. And now we're finally coming around to the point of saying, okay, well, what can we do about that?
Yeah.
That's an interesting specific one to look at. And is that still on chain on pre-prod where we can look at it?
I was having trouble finding. It's been a couple of months, so I was having trouble finding it again. But I don't have my contributor token, so it must be somewhere stuck also on this.
Well, we can find, this is actually interesting. We could find your contributor token by, I mean, we could find it on Cardano scan too, right? Do you remember what you called it?
Yeah, mine is North Jetta.
That's right. So we could take this token name. We could convert it, and we're going to grab that. So there's a policy, there's a token name, but we need the policy ID as well. What's the policy ID of that token?
I was thinking it always goes between my wallet and like the PBL wallet, right?
Yeah. Oh, whoops, why didn't that work? Oh, here, let's just do it this way. It's a very inefficient way to find the thing. And you could probably follow the same process. Anyway, but yeah, we need to find it. I know it's not locked in the PBL course, right?
Oh, you already know this. Oh.
Yeah, I mean, if it was locked in the PBL course, we would see it here. And so
Yeah.
this is the list of currently locked commitments.
Oh, yeah, I was checking there.
Seb's been busy. I thought I just distributed this thing. He's got another one in there. So yeah, it would show up in this list if it was currently locked in a commitment.
Oh, it's not locked. Okay.
Right.
Then it's somewhere in my jumble of old mess.
But there are several things in module 204 that are also worth looking at if what we realize is that we want to spend some time thinking about some of the front end stuff. That's a place where we could go and we could try to look at the metadata in there. So there's two options for what we could do today. Let's pull this one over here with this cheeky question, but I think it's worth asking, along with this bigger picture goal. That's a way we could spend our time. Installing Node on Kali Linux. Oh, okay. If you're to whoever has this issue, are you trying to download the binary? I'm not sure who added this one.
Or building it up from source, and then
Yeah, exactly.
And
That's
what have they
complete
tried
zone.
so far? Yeah, this is something that I'm really keyed on. I really think, I got some experience because I feel like it's really necessary, like being able to install that and get it going on your local machine. Just the foundation for all of this.
Yeah, I would say it's likely if you're trying to use the executable, but it doesn't work, it's probably best to try building the node from source. I imagine, I don't think IO is supporting like a compilation, and I don't know much about Kali, so I can't speak for that. So that's just my first guess. Well, we got a few different directions to go here. And so for the first time in a little while, let's do a quick vote on this. Because any of these could be a great move today. Here, one more time for anybody who just showed up, here's the Miro board we're working within. Oops, that didn't work. Try that one more time. Nope. Just gonna do it over here. And if you could pop in here, what you'll be able to do is vote on how we spend our time today. So what I'm going to do, let's just make a little zone right here. And you'll vote by selecting a box, a breakout room box, not a sticky note. So that's what we'll enable here. And you get one vote. All right, and if you don't have access to the Miro board, feel free just to type a number 1, 2, or 3 into the Zoom chat to represent what you want. And that's how we'll decide how to spend our time today. Any questions? All right, let's try it. So voting is open.
Oh, here we go. It's, yeah, I don't want an electioneer or anything. But I'm voting for, because what you're voting for is like, what do we record? Like what stays on? It's like, I am voting for 1 because I want it recorded. Oh crap, I'm not voting. I can't vote.
Oh, really?
Yeah. Can you guys vote?
Is it
I'm
working?
signed in.
Feel free just to type
Yeah.
numbers into the Zoom chat too, just for.
I
Okay.
don't want to influence the vote. So if it was the summer of governance, what is it? The fall of something else. Yeah.
What comes after governance? All right.
Man.
Number 2, and in the chat, number 2 got 2 more votes, so 7-3, pretty clear. We should dive into that. What I'll do is just open up a couple breakout rooms right here, just in case anybody wants to use the space to have other conversations. And there's also a room 4, which you could just use for anything. But like Newman said, for this room, which is the one being live streamed, let's focus on this bit right here. Okay. And is it okay with everybody if we go back and forth between these 2 questions a little bit? I'd like to think about how we talk about the EUTXO model. And while we do, look at a couple of validators whose job is to store UTXOs, which is a key part of the EUTXO model. And so we'll go back and forth and we'll try to build up our understanding about both of these. And we'll know we were successful if about an hour from now, Alex has a good answer to the question, why bother? How's that sound?
So I'm going to jump into a breakout to work on this. I realize that I've got to have some, I got to get, because I think Harsha is way ahead of me, and Faizan is way ahead of me. So I got to keep up with my brothers, and I'm going to jump in on one.
All right. We'll see you soon.
Okay.
Thanks, Steve. Okay. The other thing I want to do is be able to look at some UTXOs via Cardano CLI. Just got to start my node. And just for fun, you guys have, a lot of you have seen this before using Cardano CLI. But does anybody have an address that has, on pre-prod, maybe some different assets in it that we can look at together? If you drop one in the chat, we can take a look. I'm syncing up over here. I just need a few moments to sync up pre-prod. And Sebastian's got an address. Thank you, sir. Let's use that one. And then we'll look at Harsh's as well. Okay, we got a few options. Excellent. Thank you, guys. All right, so we'll just look at this one first. So right, I can query the UTXOs on pre-prod at some address. And even though my node is not perfectly synced yet, I can still see the UTXOs there. And this might, if there have been recent transactions, these might change. So far, still the same. But this right here is a UTXO, right? It's a special UTXO because it's extended. So what does that mean? First, let's just talk for a minute about the E in EUTXO. This is very similar to how tokens are handled on Bitcoin. And so Bitcoin invented the UTXO model, where you just have Satoshis, right? The bits of a Bitcoin, just like Lovelaces make up an ADA, Satoshis make up a Bitcoin, and that's what you have in every UTXO on the Bitcoin blockchain. And whenever you want to send Bitcoins around, you're going to consume some UTXOs, one or more, and you're going to create some new ones. And we could go deeper into that, but in general, how do people feel just about your understanding of the basic UTXO model? Questions about that? Okay, and that we can revisit that anytime, and whatever concepts we have to, we can go over that. Now on Cardano, we have UTXOs. They're represented similar to how they are on Bitcoin. And just like you can have Satoshis in a Bitcoin UTXO, you can have the sub parts of an ADA called Lovelace in one of these. So here's a UTXO that has almost 2,400 test ADA, right? Or basically 2.4 billion Lovelace. But that's not all it has. It also has some other tokens. And this is one of the reasons that this is called the extended UTXO model. Now on Cardano, we don't just hold the network token, but we can hold any other arbitrary tokens that we've minted. However, it doesn't even stop there. It gets even more interesting when we look at this last bit that we can see from the Cardano CLI view, the datum. In addition to holding Lovelace and tokens, extended UTXOs can just hold some arbitrary data. And that's called datum, and it can be used in applications that are working through Plutus smart contracts. And that's extremely exciting, right? So Bitcoin gave us the ability to just break money into parts, right? And to have UTXOs to represent different tranches of money, right? And some people have compared UTXOs to like paper currency, right? a $5 bill, right, is unspent when it's in my wallet, but when I go to the store, I spend it. Fine. What Datum does is it allows us to put information on that money that dictates rules about how it might be spent. And this is where validator contract addresses come in. Not only can UTXOs be held in somebody's wallet address, but they can also be held at contract addresses. And so how are people doing with this concept, right? If I say that a Plutus validator is kind of like a customizable spending key, does that make sense? So Sebastian's wallet address, right, was derived from some keys, public and private keys. And whoever holds the private key associated with this address can spend this UTXO. And that's how Bitcoin works. What Cardano and Plutus give us is the ability to write custom rules that replace our private keys. So that instead of sending funds to somebody's wallet where they can spend it, we can send funds to a contract address that's not unlocked by a spending key, but's unlocked by the custom validation key that you've written in Plutus. And if that idea makes sense, you're really ready to roll. So who has questions about that? That's a big idea. It might be obvious to some people at this point, but if you're still kind of getting this idea, what questions do you have now?
So the custom validation key that we write through a smart contract, it uses the transaction datum as a part of the logic.
Always. Yeah.
Okay.
And so this is one thing that we have to be careful of, right? Is if I do write a validator and I want to send UTXOs there, I must include datum on those UTXOs.
Got it. Got it.
Now, a UTXO that's just in your wallet optionally can have datum on it. Okay, so every UTXO at a contract address must include datum. But if you want to, if you can think of a use case for it, you can also use datum just at any wallet address. And there are actually a few innovative use cases that are starting to emerge for that. All right, I'm fully synced. Let's just make sure. Okay, we were fully up to date. That's the current UTXO snapshot for this wallet. Okay. Now I want to look at a completely different address now. Instead of looking at a simple wallet address, let's actually look at a contract address like this one. Watch this, ready? Oh, Akash, exactly. So I want to get into that question. And datum is one of the major topics that we're going to cover in modules 301 and 302. So you're going to start seeing a lot more of this. But here's a contract address that has a whole bunch of UTXOs in it. You see how far I had to scroll right there? Each of them has like a little bit more than one ADA. This is like a min UTXO amount of ADA right here. And then each of these has 1, token that appears to have the same policy ID for each one. You see going down, all of these singleton tokens have the same policy ID, but each of them has a different token name. For example, like this. And then each of these has some datum. Now we can read this a little bit right here. For example, if I scroll down, I can start to see, here's an example of a datum that includes a bunch of information in it. In this case, it's a list of the modules somebody has completed in this course. And that's on chain. And if anybody here has seen the lucky number assignments, those lucky numbers are also in this datum, for example, right here. So this UTXO holds a token and a datum with a lucky number of 7 and a list of course accomplishments. Now, as you're looking at this for the first time, does that raise any questions for you? Would it be fair if I called this UTXO an extended one? Does that feel like a good word to everybody? Sure looks like it holds a lot more than just some lovelies. Now, obviously, Cardano CLI can be a little bit limiting. All right, it's bugging my eyes out just to look at it this way. So one thing you should know about Cardano CLI is that you can always run these commands and like specify an out file, for example. And I'll just call this one example.json. And so now instead of printing this to my terminal, I now have a file called example.json that I can look at. And it's a little bit nicer. All right, so here's a different way to view each of these UTXOs. Here's the transaction hash and index. Here's the address that that UTXO is stored at. It's the same for all of these because that's what I just did. I just queried UTXOs. And here is some datum. And it's formatted a little bit differently than a minute ago, but it should look familiar. Right here is a lucky number. And right here is a list of accomplishments. It's just that now in this view, we're seeing these accomplishments closer to how they're actually stored on chain as byte strings. And each of these can be translated from hex into the string that it represents. Seb, what do you think?
Yeah, that extension, that JSON has some kind of influence in the way the file is shaped in this file. That
Good
JSON.
question. Let me try. Like if I don't call it a JSON file,
Sure.
and I just call it like text, for example. Let's see. That's the same. Yeah, it's formatted as, we can call the file whatever we want, and Cardano CLI, when we ask it for an out file, it formats it like this.
Okay, another question. The UTXOs in Bitcoin, in the way that you are showing this information of the UTXOs. Those UTXOs only keeps satoshis, not also tokens or something else.
I would need to check to give a perfect answer to that. But as I understand it, the UTXO from Bitcoin can only hold Satoshis,
Only Satoshis.
right? However, a Bitcoin transaction can have some metadata written on it. So you can write some arbitrary information onto the Bitcoin blockchain, in the same way that we can add transaction metadata to a Cardano transaction. But notice that metadata is different from the datum we're talking about here. Okay, datum exists inside the UTXO itself, whereas metadata is included separately on the transaction, the action part itself. Areas, what's happening?
Yeah, hey James, hey everyone.
Hey.
You mentioned that the policy ID is the same for all of those transactions, I think it was, but that the token name was different. Can you explain that a little? Thanks.
100%. Yeah, let's take a look at that now. So another cool thing about viewing the information this way is actually this view of a UTXO, I should be more specific, of an EUTXO, is helpful for other reasons. And one reason this is helpful is we can see how value is stored inside of a UTXO. Okay. Now, one rule about using Cardano is that every UTXO has to have a minimum amount of Lovelace in it. And we typically say that it's about 1 ADA. There's people who have played around with it and they've realized that you can actually create a UTXO with a little bit less than 1 ADA in it. But for simplicity's sake, we'll say that in general, you have to have about at least 1 ADA per UTXO. And then if you include other stuff in it, like datum, or maybe like other tokens, and there's another case we're going to look at in just a minute that makes the min UTXO much higher, but we'll get to that, right? You can see that right here, this UTXO required a little bit more than 1.26 ADA or so. Okay, so there's our Lovelace. Then inside the value, we have any other additional tokens. And if you have a wallet with any NFTs or DeFi tokens or anything else in it, all of those tokens are represented in this way. But the JSON format of this is actually really helpful because look what it says. It says in the value, I have objects, and those value objects each have a key, which is the policy ID. And then that policy ID points to another object that then has the token names to go with that policy ID. And we can see the quantity of each. Policy ID, token name, quantity is organized like this. Now, to Aris's question, why does every UTXO at this address have a token with the same policy ID?
Can I guess?
Yeah.
Is it those are the initial NFTs that we had to do at the beginning?
Yeah, but they're not the one that went to your wallet. This is the same policy ID as the token that went to your wallet. You can look, they match. But when you, in lesson 100.4, at the very beginning of this course, when you mint your contributor token, you actually minted 2 tokens. And you got one of them in your wallet, and the other one was minted to this contract address. And for anybody who has read SIP 68, or if you've heard hype about SIP 68, we're not following the whole thing here. We're not using this datum right here to represent typical NFT metadata, but we are following a critical piece of what SIP68 suggests. And what that is this concept of matching the token in your wallet to a reference token somewhere else on chain. And this address, this one, and I'll put this in the chat just in case anybody wants to play with this address in any other way. You can look it up on Cardano Scan. You can query it yourself on Cardano CLI to look at the data that I'm looking at right now. This is a contract address where all of the contributor reference tokens are held. And this has a few benefits. First of all, because all of these reference tokens are at the same address, we can query this in the front end, get all the same information that we're looking at right here, and we can make it look more presentable. For example, we could take the data that we're looking at in my terminal window, and we can make it look like this. And this is what you see on the Plutus PBL website. All of this information, all the data we have about how many people have changed their lucky number, right? 29 out of 176. All of the data we have about who has mastered which module. This is all coming from the very same query that we were just looking at in my terminal window. But it's processed, and we're starting to turn it into something a little bit more user-friendly. Is this as beautiful as it can get? Absolutely not. And so this is a message I share every couple of weeks. We're trying to build ugly front ends so that you want to build something better. Okay, so anybody here who wants a chance to learn something and to practice their front end skills, one way you could choose to do that is you could say, oh man, look at those amateurs over at Plutus PBL. I can make something prettier than that. Or here's another way, right? On this page, we have two different ways of looking at the same data. Here's a table view. Actually, this one is searchable. So that's kind of cool, right? But even that, I don't know, it's not that pretty. And so this is just a playground for you to play with presenting on-chain data in useful ways. Sebastian.
Yeah, the difference between the two tokens goes into the token name, not in the policy ID, right?
Mm-hmm.
Okay, thank you.
So, and some people saw this last week when we were playing with the front end. But now let's look at this token name. And I'll grab, let's find somebody who's made some nice, here's somebody who made some nice progress. Okay, who is this? Let's try to find out. So Datum shows a bunch of module completion. And first, just to show you this, let's grab this string right here. I'm going to copy this and bring it over to the converter. And so what does that say? All right, you see how that string right there was module 202. So hopefully that makes sense, how we're tracking the mastery data. But now let's also grab this token name right here, copy that. And let's see, this token name converts to 100 PBL 2023. And then in this case, this is Ash's token. Okay. And that's the alias that you added when you minted your token in module 100.4. But you only got to choose the alias. The rest of this was done for you. And we've got the 100 PBL 2023. Well, let's take a closer look. Wait a minute. 313030. That's 100, right? Remember that hex characters each have 2 digits. So 31 is 1, and then 30 is 0. 100. And then after that, we've got 5050424C. That's PBL. You can see for yourself. And then finally, we've got the 32303233. That's 2023. So we've got 100 PPBL 2023. And as it turns out, all of the tokens in this list, not only do they share the same policy ID, but they also share the same prefix. I could probably search for this in my window, right? And so as I can scroll down through all of these UTXOs, and I'm going to see that that's the same prefix on all of these tokens. Okay. Now, the way we associate the token in your wallet with the one at this contract address is by keeping everything after the number 100 the same. PPBL 2023 and your alias. And you know that because you have this token in your wallet. But maybe if you've looked closely, you've noticed that there's a different number on the front of your personal token. And it's a 222. We use the numbers 222 for your token and the number 100 for the reference token, because that's what's loosely suggested in CIP 68. But it doesn't have to be that way. All we need is one way to show that there's a relationship between these two tokens. And one simple way to do it is to say, okay, two tokens with the same policy ID and the same token name after those first three digits, we're going to say that those are correlated with each other. Okay. But this method of just throwing a 3-digit number on the front of the token name, I don't know if it'll last forever. I think there's some people with some other alternative ideas, and maybe some of you right here have other approaches that we could follow here. So we have room to be creative and room to play around with this. It's not necessarily a full-fledged standard yet, and we might realize that we want to create our own. Any questions about that?
Yeah, I do. I'm wondering why the decision was made even to go with the hexadecimal format instead of just like a string that's easily readable.
This is much easier for the machine to read, right? And because the blockchain runs on machines, we really want to emphasize the security of the system by making these token names readable to the protocol. Right? Think about spaces, for example. Spaces and punctuation, there can be some ambiguity there. And, you know, imagine if these were strings, not hex strings, how easy it would be for somebody to cheat by adding an extra space in between some words that they hope you don't notice, right? By doing it this way, we don't have that problem because a space is a specific hex character and it'll show up very clearly in this string right here. Does that make sense?
Yeah, absolutely. Thanks.
Yep. And there's, you know, obviously I keep showing you this website for converting from hex to string, but in all of the projects that we're using for front ends, including the PBL website itself, we have just a little helper function. It's pretty easy to convert from hex to string or the other way around. And especially if you just have a simple helper function to do it, then you don't need to think about it. You just call that function and it happens every time. And you'll have a chance to see that when you get to it. Okay, so UTXOs, they're extended because they can have these tokens and this datum in it. But how do we use them? Okay, and I want to now shift our attention to some Plutus validators, but I also want to pin for later. Even this right here is not a full picture of the extended UTXO model. there are some other things we can do. For example, a UTXO can include a reference script. And so if you've heard of Plutus v2, if you've heard of reference scripts or deploying your contracts on chain, what it means is you can actually take the contract CBOR and place it in a UTXO just like this. Okay, and if we have time, we can look at a few of those together. When you do, what happens is the min UTXO goes way up. Every time, I think the smallest reference UTXO I ever deployed still had like a requirement of about 16 or 17 ADA in it. And I've had some bigger smart contracts that require more than 30 ADA. Okay, and so when you think about the value of ADA as a token, think about as people use this chain more and they're locking more scripts in UTXOs, how much ADA is essentially going to go out of circulation because it has a real utility for supporting dApps on chain. So in the chat, Akash asked, what is reference token versus reference script? This is a painful ambiguity right here, and we need better words. But when we talk about reference scripts, we're talking about UTXOs that actually hold Plutus CBOR in them. And when we talk about a reference token, we're using the language from SIP 68, which talks about these kinds of tokens that can be used to store datum associated with your contributor tokens. We need better clarity about that and maybe different words because we're using the word reference in two different ways, really close to each other. Seb, what did you have?
Sorry, man. In the reference script goes the CBOR of the contract, right?
Yeah, let's take a quick look at that. Because I have this up, we might as well take a look. And I have a way for us to do that quickly. So here, actually, in our front end project, this is not the PBL course, though. 1 second. This is the front end repository for the course that we're using at plutuspbl.io. And this has a primitive configuration file. We've been doing a lot of work to make this much better for Andamio itself. But one of the parameters we have here is this reference script address for the application. And by the way, I was talking about the ambiguity of reference tokens and reference scripts. This naming convention forces us to have really silly names like the ridiculous contributor reference UTXO. But there's both of the words reference being used right next to each other. So that's a mouthful. But let's look at this reference script address on chain. What's interesting is when I look at it, this way, just the typical Cardano CLI way, it doesn't look like anything special is happening here. So Cardano CLI has not yet been updated to show us any indication that there's a reference script attached to these UTXOs. However, if I run that same command and once again store it in an out file, I'll call this one example 2.json, and then I can look at that file. Here, this is the same thing we were just looking at, but check it out. Right, we've got a UTXO with its transaction hash and index. Here's the address that I just queried where it's stored. This one has no datum, but it does have a reference script. And that reference script Yeah, it looks actually just like the .plutus files that you've been compiling in this course. And it's right on chain. What do you think? And so when people talk about deploying a smart contract on chain, this is often what they mean. And once this is on chain, we can simply validate against this code anytime. In other words, right, go back to this comparison of private keys in individual people's wallets to validators as custom keys, right? Basically, what you're saying right here is, look, hey, world, here's the keyhole, right? Here it is. Here's publicly all the rules that you gotta meet to unlock something from some contract address somewhere, right? And it's all here for the public to see. You could reverse engineer this and basically figure out what the source code is. That's something we could do for fun sometime if you want to, okay? But it's right there on chain. And anybody who can meet the conditions embedded in this logic right here can unlock UTXOs from a contract address. By the way, here's the min UTXO for this one. To put this much data in a UTXO is going to cost me more lovelies, 17.5 ADA to get this on chain. So in the chat, Alex says, this sounds like the smart contract functionality, but what's the difference with the reference script? It's not the same as locking ADA at a validator address. Exactly. Okay. So no, nothing changed about how we lock UTXOs at a validator address. What changed is where we can reference the logic from. And in Plutus v1, all of this right here, okay, this script object had to be provided as a file in every unlocking transaction we write. And that's clunky, right? First of all, you got to pass that file around, right? And so if I wanted to collaborate with somebody, I would have to upload that compiled CBOR maybe to a Git repo where other people could access it. I've sent these files through Discord a few times, right, just to share it around. But that's a pain in the ass. The Cardano blockchain is already a storage layer that we all share, and that's why I forget what SIP it was, like 31 or 33 or something. That's why it was suggested in a SIP, hey, why don't we just put Plutus scripts on chain? Yeah, it'll be expensive, right, as referenced by these higher minimum UTXOs, but this is very convenient. And yeah, I want to be able to just reference this. And so first, now we have the ability to put this on chain. And then let's just look at the Cardano CLI transaction build documentation. Okay, so the Plutus v1 functionality is actually still here. If I'm trying to spend TX in from a contract address, I can still just include the script as a file, TX in script file. This works for Plutus v1 scripts. It works for Plutus v2 scripts if you don't want to deploy your script on chain, that's fine. It also works for native scripts, okay? You can always just include the file directly in a transaction. But just like the scenario I was describing a moment ago, you don't have to. If it's been deployed on chain, instead of including the file, you can just reference a different UTXO. Spending TX in reference. You supply it with a TX in just like a spending TX, right? All I need to know is that transaction ID and hash. And then there's a few other things I got to specify. I have to say, okay, that reference script that I'm passing here, it's a Plutus script v2. Eventually, Plutus v3 is going to come out. And so another tag might be added here. We can't remove this one because we have to ensure backwards compatibility. Anything that's already built and deployed on Cardano has to continue to work as Plutus continues to develop. However, there's going to be further tags added as time goes by. If you don't want to use a Plutus script, you can also just use a simple script TXN reference. Okay, that's for native scripts. So I can put a script on chain and reference it as many times as I need exactly. These UTXOs that we were just looking at up here can be referenced over and over again without ever being spent. And that's a critical concept. It's so important. Okay. What this means also is that, yeah, there's an upfront cost to storing a reference script on chain. Here's that min UTXO, but I can always get this back. If I don't need this script on chain anymore, I can spend this UTXO and just reclaim this 17.5 ADA. Okay. But as long as this is up here and I'm using it, there's a much lower transaction fee to use a reference script in the way we were just looking at right here than to include the file every time. And so you can, this is like a 9th grade algebra function. You could figure out where you would break even, how many times you'd have to use your contract in order to pay for this higher min UTXO right here.
Yeah.
Now, sorry about the sirens. Seb.
Sorry, man. I was thinking about, for example, if someone build a service where the clients, the users have to use as a smart contract referenced in a UTXO. In some each time the users invoke that UTXO, there is a way to charge some kind of fee for the use of that smart contract for that reference UTXO.
Very good. Okay. Awesome.
This is thinking about business.
I love
business
this.
models.
I love this. Okay. So the functionality you're describing is not built in on chain. In fact, the default behavior is the opposite of what you just said. Basically, once I deploy a reference script on chain, I can't stop other people from using this just by using the basic functionality of the chain. However, what I can do is when I write the validator itself, I could include in the validator code that every time there's a transaction out of this validator, some fraction of Lovelace has to be paid to some other address. That's how royalty contracts work. People are already experimenting with it for art, but I think software royalties done this way is going to be a really cool thing for us to explore. And that would be a great example. Just like we have, the project in module 204 is a very basic example of a token gated faucet. If you have this token, you can get that token. And I hope that other people here, as you've done that project, you've had some other ideas for how to go a few steps further than that, right? But we could actually build a similar simple project that just has a validator that always pays a royalty to some address. And we could look at that pattern and play with it. It sounds like a fun project.
Yeah, thanks, man.
You know it. Okay, well, okay, Alex, I'm going to put you on the spot in 8 minutes because you got to answer this question, who cares? But before we do, now let's take a quick look at a tiny bit of validator code. Okay. I want to take a look together at an example of a validator that does what Alex asked about at the beginning of this session, right? It talks to another one. So this is a topic we're going to go deeper into, particularly in my, but here's a little coming attraction. Shoot, what is it going to be? I think. Now I'm not actually sure where it is. I think it's in here. I got to double check which one of these we're using, but this will give us the idea. Okay. Under the hood of the Plutus PBL course, allowing you to commit to modules and then unlock them when you're complete are two contracts. We have a treasury contract and an escrow contract. Now, at a surface level, these two things do what their name implies. The treasury holds a bunch of tokens that people can draw from. And then escrow basically sets aside those tokens after somebody makes a commitment to doing a module, and it holds them until that commitment is complete and it's been distributed back to you. In other words, whenever you've made a commitment and it's visible right here, the reason it's visible right here is that your commitment causes, in this case, what's this, 2 ADA and 10 test gimbals to be held in escrow. That's what escrows do, right? They hold funds while two parties wait for something to happen. And so in this case, what's the thing we're waiting for? We're saying, okay, Sebastian committed to doing module 203. And if he does it, he's guaranteed to get these rewards. They're already locked. They've already been pulled out of the treasury and set aside for only this contributor. I'm very passionate about this approach. I think this is a lot better than bounty systems, because bounty systems, they show you a list of tasks and you look at it, you say, oh, there's a 50 ADA reward for that task. I'm gonna try to be the first one to do it so I can be the one to win that bounty. And suddenly I'm in a competition with other people who are also trying to be the first to win that bounty. And I might do all the work, but be 5 minutes behind Sebastian, and he gets all the rewards and I get none of it. That's how a lot of bounty systems work. This is different. This allows us to say, okay, hey, you said you're going to do this work right here. We're setting aside in escrow the rewards for that. And as long as you do it, you get these rewards. Nobody can beat you to this. You're not in a competition anymore. You can relax and get this work done like a real human. Okay. This is the system we're building. But maybe you're starting to see that the treasury and the escrow are going to have a relationship. Okay, you do have a deadline one, that's true, but we're hoping to keep it a reasonable, people positive, human centric kind of deadline, a fair amount of time. So really what we want is we want this treasury to only be unlocked if it's sending some tokens to an escrow. We don't want people to be able to come along and take all the tokens out of this treasury, right? We only want contributors to be able to say, I want to do something, and that unlocks the treasury validator and only allows those tokens to be sent into escrow. All right. So here's when somebody makes a commitment. We're not going to cover all this right now because we only have 3 minutes. Okay. But when somebody makes a commitment, one of the things we check is that check value to escrow contract. Okay. Here it is. We're checking that the value of the commitment is going where? To the escrow contract. And the logic for this is a little farther down the page. And this is a function that we're going to look at very, very closely together in module 302. This is a really good place to start learning some things. But at a high level, this gets us to the answer to Alex's question. What I'm able to say is in my treasury parameters. Let's look at those for just a minute. Treasury parameters are in my types file over here. Treasury param. Oh, it's right at the top. Okay. To create a treasury, I must specify an escrow contract. And the treasury that I create right here with these parameters is only going to be able to work with this escrow contract. Okay. I'm going to pause right there. There's a lot more to do right here. And I'm really excited that we're taking our first look at this together. By the way, there is also a relationship between these contracts and the one that updates your contributor datum at that contributor reference contract. But we'll also look at that. Either we can keep going tomorrow or some week soon, or like I'm saying in module 302. So quickly, questions. Yes, Erez, this is how royalties can work. That's one way to do it. And yes, you can put a time limit on the escrow contract. In fact, in the project details down here, which are used in the escrow, an expiration time is specified, and it can be anything. And basically, we do this off-chain, defining what the expiration time is. Currently, the way the PBL course is built, you have at least 30 days. Okay, well, if you make a commitment to a module, nobody can erase your commitment until at least 30 days after you make it. Right? We could change that number to 20, to 60, or whatever people feel fit.
But you can also add some variable in terms of
Yes.
additional tokens, for example, to incentivize the contributor to keep the pace.
Right. It's
Not wait
possible to update the escrow transaction, like right here. Mhm. Yeah. Vesting is related to this. Anytime we handle time, we're on our way to thinking about vesting. Good. Yeah, we can keep going. But as promised, Alex, I want to hear your thoughts. What do you think? Have we shown a good reason for this functionality to exist?
No, it was really interesting because I didn't know. Can you hear me?
Yep.
So yeah, what you described in the treasury and escrow is an incentive model, right? And we happened, I think, to stumble upon different incentive model which we are using implicitly, but we are not capitalizing or like not tokenizing it properly. So yeah, and this would be paid for attention, like Brave browser bot token. But anyway, well, so yeah, I'm working on this, and also on exactly the idea of how to connect several smart contracts in one, and like it's a very new piece of software, and documentation is still in the creator's mind. So I'm kind of gathering the pieces as I go, and yeah. So I think the architecture where you have more than one smart contract is really isn't. I didn't meet any, like, except for treasury and escrow. I didn't meet any examples, but yeah, just my perspective is limited, of course.
Oh, I've got a lot more examples we could talk about, right? Like think about progressive governance systems, right? Where your decision making is fed through some multi-step pipeline. Each step in that pipeline, for example, could be represented by a contract, and where you can only go from A to B to C to D, for example, anything with a process.
Yeah.
But that's the key thing. What I'm not able to do, I cannot reference the escrow hash in the treasury while doing the reverse at the same time. I can only do one or the other. If I try to do both, I've now created like a compilation loop that can't break. Okay. So you have to think really carefully about which direction you're going to have contracts referencing each other. And there are cases where you do want it going both directions. And in order to do that, you're usually now going to have to introduce some kind of thread token, right? And this is where, right, non-monetary, non-value tokens that are just temporarily minted to hold the state of some process in a system, right? Those are going to be really important in any case where you have to have like that bi-directional contracts going back and forth.
What's the name again? How
Thread token?
Yeah, thread token. Yeah, okay.
Yeah, like a state token or a thread token. There's different corners of Cardano development where you'll see people doing work on that. And that's the biggest change. Anybody who's been around for a little while, you know that we used to call the escrow and treasury GPTE. It's now just all baked into the Andamio platform. So we're not making that distinction anymore. And there's all sorts of new kind of decision-making processes that are part of that. And so we're using thread tokens in a few different ways to hold that state. But really, now taking this back to this EUTXO where we started, really you can think of a state or a thread token as just a way to identify the UTXO that you want. Right?
Yeah, that's
right. There's datum on chain somewhere. All I have to do is query the chain for this token, and there it is. Now I can run with that.
Yeah, that's what I'm stuck in this right now, and you're saying this doesn't help me, but I think just time will. Yeah. Thank you, because I was thinking of how to achieve this, but you actually described a straightforward mechanism which we have specially for that.
I like it. I'm really excited to hear that, man.
Yeah.
You'll keep us posted. Give us some updates as you have some breakthroughs.
Well, so what we're doing now is to have a kind of, how to call it, like, if you have Plutus at a lower level and the transaction building in Helios at like kind of opposite of that, and then because it seems that when we do things, we don't need all the functionality of the underlying software, and building this intermediate APIs, or how we call them, like just calling things like procedures and activities and things that we do, systematizing them and calling them names. And then also a very important thing, which I'm stuck right now, is writing product like requirements, like a formal description of what the thing should do, so that you can really show like unambiguously in the software. You look at the code and you look at the description, and it's like there's no ambiguity there, because this is important in the future for certification, and I think we will have in Cardano something like a dApp browser or dApp store, where in order to like have your app, you don't have to submit it to Google, but just you have on-chain certificate, and some kind of chain indexer will look it up, and so just dApps will be referenced through one of their contracts, and this contract will like transactions, so will be a certifying transaction which will store in the data in a datum references to the script addresses and things about audit, like the web address of like where they posted and who did the audit. And then if you do this, you can, like, the dApp store can find your app, and this is a very good way to deliver the app to the user.
Mm-hmm.
Yeah. So this Lace like is working on this, and yeah, anyone who builds it up and wants it to show up should. And this is the biggest problem right now, because like small validator is it's unique CBOR hex, yeah. And but like first, if you can parameterize, and then how do you certify parameterization? This is the topic of certification working group for the next 6 months.
Incredible.
With Ali championing, and yeah, and the second big thing is like this doc that I sent in the beginning. It says that multiple smart contract architecture is difficult because it's difficult to formally verify. It's complex. So, like, well, on the other hand, you can build a very complex validator, and there's like trade-offs to that and that. So yeah, that's seems to be the future of our building in the next 6 months.
Good. That's the cutting edge. That's really exciting.
Yeah, it's pretty cool. I think we can maybe try to steal the Harsha has a hand up.
Oh, I just had a question from the previous discussion. I was just curious as to how, if I deploy a script on the blockchain and I wanted to share it with someone so that they don't have to spend the extra Lovelaces. So I would share the transaction ID, the transaction index, and the logic of the validator through Git. Is that how it's done?
Right. Yeah. So you would share like you said, the hash and index of the UTXO is enough for the on-chain part. And then obviously offline, you have to somehow explain to them how the validator works. And so you can, right? But you can do that. This raises a more interesting point. In these early days, we are often doing that by sharing the source code for our validators. And that, of course, that's one way to do it, right? But first of all, that's not user-friendly to most people, right? You have to know how to read a validator in order for that to be helpful, right? And maybe a better way to do that is documentation. But this then leads to a more interesting point that we're going to see. We could debate my opinion here, but I believe that there is ultimately a somewhat finite number of contracts that are ever going to need to be written, right? There's a lot of them. There's a lot that we can play with, but there's certain use cases that once that contract is built, it doesn't need to be written over and over again. And from a practical perspective, there's absolutely a finite limit to how many contracts we can deploy on chain. There's only enough Lovelace, right? Divide the number of Lovelace in circulation by how many contracts people might want to deploy, and the min UTXO. And you can see that clearly there's a limit to how many reference scripts can go on chain. Okay, so it's going to be interesting, because once that happens and that contract is deployed, I don't need to tweak the source code. If I tweak the source code, I'm going to change the contract anyway, and it's going to have to be redeployed. At a certain point, this is a piece of hardware. Right? We're going to start to understand that smart contracts are serving a role more like the role of hardware. Unchangeable, we just count on them to do what they do. And where the real work is making creative use of those contracts that now exist.
Got it. Got it. So you eventually, do you see like a big library of like reference UTXOs and contract logics? Is that what you're?
I think so. Yeah, I mean, already Hydra is doing it. If you want to play with Hydra, you have to get the transaction hash of the Hydra reference UTXO. And once you have that, you can start using Hydra, right? So it's already happening. And this, we're in such the early days of this that we're still kind of just making sense of it and establishing the way of talking about it. But once there's a handful of examples out there, it's going to really start to click very quickly for people, right? But we talk about Cardano being a layer 1 protocol, which implies that layer 2 protocols are built on top of that. What does that mean? What does it mean to add a protocol layer on top of this one? There's a few different ways we could interpret it, but a big part of it is going to be, hey, to use this layer 2 protocol, I'm using this set of smart contracts that are already deployed and ready to go. And now, what's the work of the off-chain code? What's the work of the JavaScript developers, or even the libraries we provide? We can start building tools and libraries that are specifically for using certain smart contracts that most of the time are just going to be there doing their thing like hardware in the background while we build innovative things on top of that protocol.
Makes sense.
What do you think? That's where we're going together. This is what's happening right now. Exciting times. Seb, tomorrow, please. What should we definitely prioritize for tomorrow?
The continuation of this talk about the validator and the smart contract, the treasury and the treasury smart contract that you are talking a few moments ago.
Awesome.
Treasury and escrow.
That's absolutely something we can jump into. And this is helpful to me to start thinking about. This is helping me like think about where we'll fit these details into module 302. So I love the opportunity. And yeah, there's some stuff with the treasury that we haven't looked at yet. That's pretty exciting. Dan.
Very quick one. Do you see a situation where there will be competition among smart contract writers as to who charges the least for use of their contract? Because obviously, if you're putting contracts on chain, it would be nice to get a reward, even if it's a fraction of even if it's a Lovelace or two. But somebody else might go, well, you're doing it for 2, I'll do it for 1, and have the same functionality. So yeah, just a thought.
How could there not be a race to the bottom there, right? Oh, we provide that smart contract functionality and we don't take a cut is always going to be a sales pitch that appeals to some people. Right. So now the real question becomes, well, if you are taking a cut, where does it go? Does it go to a treasury for public goods where it's turned around and has a track record of making investments in such a way that people are happy to pay that transaction fee every time? Oh, maybe you've got something there, right? But are you taking a huge slice just because you can? Like people vote, the market speaks, right? Like people are just not going to use that if there's not a value in it. And so your question, I think, is a great starting place for our next round of tokenomics conversations, because I don't think you're going to capture value just by taking a cut from smart contracts. You're right. I don't think in the long term that's going to be an approach that works. What we have to understand is that the smart contract is an element of a tokenomics backed protocol. And if that delivers enough value so that the protocol is valuable, then the smart contract developers are going to be remunerated in that kind of indirect but very real way. Martin, what do you think?
I found my token in the wallet.
Yes, we've closed several loops today. This is great.
And yeah, I've checked the GraphQL, and there are several things. I think I'm not the only one who made this mistake, but I'm not in the faucet aggregator anymore. So
Oh, excellent.
it's something that has been fixed.
There were a couple things going on there. Yeah. So in addition to continuing the exploration of the treasury, the other piece of ongoing work ahead of us is various troubleshooting on the faucet project. Okay. And I hope people will be generous and think of these things as Easter eggs, not as bugs, right? What we tried to do with the faucet project is create a space where the goal is simple enough, right? That of a token gated faucet. And this concept of aggregation, you can start to make sense of how we're playing with the aggregation concept. But at the very same time, there's some design challenges to both parameterize smart contract aggregation and then even the pattern we're using to get you in there. And those challenges are actually a critical part of what we're going to cover together in this course. So we definitely have a few really interesting working sessions ahead of us, making sense of that. It's very imperfect, the system you're seeing in the Plutus faucet project, but that's on purpose, right? We want you to have a project to kind of sink your teeth into and to start having some better ideas for how aggregation might work.
So yeah. What do I do to
Let's
proceed?
maybe that should be our focus tomorrow. I do really want to get back to the treasury, Seb, but I think it's more timely to dig into the faucet first. And both really the faucet project is set up to be kind of a first look at some concerns of validation and front ends that are then going to inform how we go deeper into the treasury and escrow stuff, which is several degrees, more advanced than the faucet.
Okay.
So yeah, let's preliminarily plan on taking a look at module 204, the faucet project tomorrow, specifically in this way of troubleshooting. Okay, so like, why is Martin's example not showing up? Are there others that are not behaving as expected? And what can we do about that? Cool.
I dig it.
How was your working session, Newman?
It went well. I'm almost to the finish of it. But yeah, payment keys into Bash script, and yeah, it went pretty smooth. So I've almost got a new token out there in the pre-prod.
Congratulations. Y'all, thanks for being here for this. Thanks for following along on that wild ride today. And always, right, if you are reflecting on some of the stuff we looked at and you come up with a question 10 days from now, be sure to write it down, drop it in Discord or bring it to a future live coding session. We're here to work slow, to work for the long term. And so on your pace, wherever you're at, I hope you'll keep showing up with whatever you got. Till next time. Thanks, everybody.